Hello, geometry classes. We are going to start a new unit today. Unit 13 is our final unit, and we're going to get into surface area and volumes and three-dimensional shapes. Before we do that, we're going to play with the flat shapes, like a circle instead of a sphere. So we have this thing called geometric probability, and anytime I do probability, I always set it up. What do I want? Put it over my total. And then I'm allowed to divide that, and that answer will be my probability. So we're going to use that general idea today. A probability is a number from 0 to 1 that represents the chance that an event will occur. The zeros are kind of unlikely to happen. Sad face. And then the closer to 1 you get, it's very likely to happen, which is usually a good thing. Well, geometric probability, it is a probability that involves a geometric measurement such as length or area. And those are actually the two types we're going to figure out. How do you do probability with length and probability with area? Well, if you're going to do it with length, there's going to be a specific length that you want. Again, I'm putting my want on top. And on the bottom, I have to use my denominator as the total length. So it still has that want over total setup, but you have to think, okay, I want this length. This is my total length. Same thing works with area. There is going to be a specific area that you want. It goes on top. And on the bottom, you divide by the total area of the entire figure. So again, it's what do you want? Put it over your total. We can kind of sum it back down to that. Now, you're going to have some interesting descriptions and pictures today. So down here in example 1, each circular hole on our target has a radius of 0.5 feet. If a beanbag is equally likely to land on any point on the target, find the probability that the beanbag goes through one of the holes. Okay, so when I'm looking at that picture, you see 4 circles, and then there's this big square or rectangle going around it. And we need to find all of those shapes. So I'm going to start with the square. That's kind of our total figure. So if I want the area of that rectangle, well, area is length times width. It is a 3 by 4 rectangle. 3 by 4 is a total area of 12. The circles in there. Okay, we're going to do area of the circles. Well, the area of a circle is pi times the radius squared. In this case, our radius of each of those is 0.5. Well, pi times 0.5 squared, when you type that on your calculator and simplify, you should get 0.79. Now, there are 4 of those circles. So I'm going to times this by 4, and all of my circles together, I got 3.14. Now, when I go to do the probability, I want to get my beanbag to go through one of those circles. So I want the circles, and then the total shape here, well, if you kind of skirt along the outer edge, that's the rectangle. If I want circles, the circles were 3.14, the rectangle was 12, and when you divide, you have a probability of 0.26, or a 26% chance that you're actually going to win the game and get the beanbag in the hole. So you got to look at the shapes, itemize them down. What do you want? Put it over your total. Let's try example 2. Example 2, you ride to work on the bus. The bus comes every 15 minutes, and the ride to work is 31 minutes long. You arrive at the bus stop at 8:24 a.m. What is the probability that you will be at work by 9 o'clock? Okay. So we don't want to be late. So I'm going to work a little backwards here. If I need to be at work at 9 o'clock, 9 a.m., and I have a 31-minute ride to work. Let's work backwards. Minus 31 minutes for our ride. Then I kind of have, that takes me back to 8:29. Okay, that's the most absolute latest we need to leave by. Okay, we don't want to be late. We can't leave later than 8:29. Well, if we got at the bus stop at 8:24, the shortest we would have to wait then, from 8:24 to 8:29, that's 5 minutes. A 5-minute wait, we'll say. Or the longest we may have to wait, if we just missed the bus, we gotta wait the entire route for it to come back. So we could have to wait a 15-minute maximum, which would be that. So our desirable situation here, we would really want that 5-minute wait, but the total, it could be a 15-minute wait. So we've got 5 over 15, and when you divide, that is 0.33333, keeps repeating, so 0.33, you only need to go 2 decimal places. That is your probability of making it to work on time. 0.33 is kind of a low number, so hopefully you have a nice boss, otherwise he's going to get very angry when you show up late. On example 3 down here, we're back to using pictures. The shaded area in the diagram of your backyard shows the area that you can see from your window. If a child is equally likely to play in any part of the backyard, what is the probability that you will be able to see them from the window? In other words, what's the probability that they're in the shaded area? Well, that shaded area kind of looks like it's not a triangle. It doesn't come to a point at the bottom, but it has a flat edge, which my pen will line up. It's got a flat edge down there and on the top. It's actually a trapezoid. And then the greatest shape going all the way around the outer edge is another rectangle. So let's start with the biggest shape in there, the rectangle. We're going to find the area of that. Well, it is 64 on one side, and if it's a square, then we're 64 all the way around. Is it 64 all the way around, though? When you go to the bottom, you've got 27, 5, and 32 down there. 27 plus 5 plus 32, that is a total of 64. So we are good. It is actually a square. Be real careful on that one. You got to prove that it actually is. So for our area, we have a 64 by 64 rectangle. That is an area of 4,096. Big number. Well, next we have to tackle that trapezoid in there. The area of a trapezoid is 1/2 the height times base 1 plus base 2. We did our area earlier in the year, but you might be a little rusty on those. So if we're going to plug in parts here, the height of our trapezoid, if we were kind of going straight up and down here, well, that's the 64 height along the left. So we got 1/2 64 times base 1 and base 2. Well, base 1 is across the top, base 2 is across the bottom. The top has a total length of 64, plus that tiny, tiny little bottom segment that I probably just drew over, that has a length of 5. So that's the equation that we need to simplify. I would do 64 plus 5, that's actually 69, times 64, divided in half, and you should total out at 2,208. Now, in this problem, we really, really want to be in that that trapezoid shaded area. The total here, well, that's your rectangle or your square. So the trapezoid, 2,208, divided by your rectangle, 4,096, is a total probability of 0.54. There's your probability. The pictures tonight, you are really going to have to pay attention to. What shapes are in there? Can you break them into smaller shapes? What do you really want in this problem? What is that final biggest shape? If you kind of went around the outer edge, if you traced around the out edge of the circle or the picture. So be really careful with your setups when you're working tonight.